Alright, let's continue on our chapter 3. Now we are going to talk about um, what's called the percentile, right? What's called the percentile. So let's go through this PowerPoint together. So percentile is basically arranging the data in ascending order. So to figuring out the index i's, the position of the p's percentile, basically it's like this. Let's say you have 100 data point and you want to figure out what would be the position of 40th percentile and how do we find that, right? According to this formula, actually let me actually go through this formula with you. So let me open up the blackboard. Okay, so according to this formula, I is equal to P over 100 to the N, and I being the position value and N being the total number of data point. So let's go through the easy example. Let's say you have 100 data point. When you say 90%, you are in 90 percentile, that means behind you there's a 90%. Above you there's a 10%, right? That's what percentile means. Let's say you are in 80th percentile. What does that mean? That means you are in top 20%, right? 20% is above you and 80% is behind you. That's what percentile is. So if you really think about the position value, let's say if you're looking for 70th percentile, if there's a 100 data point, that must be the 70th data, right? So, percentile 70 over 100 times, if there is a 100 data point, this cancels out. It turns out to be 70. So I, the position value, is going to be 70. However, let's say there is n being 200, right? There are 200 data points, and you are looking for the 70th percentile, right? So same formula. This is the basic formula, right? So if you're looking for the 70th percentile in and the total number of data points being 200, so basically you are looking for which number is going to be the 70th data point, 70th percentile data point. That's what you're trying to figure out. So P being 70, 100, and if the N equal 200, then this cancels out to be 2. 70 times 240. So the position value of the data, 70th percentile data point is going to be 140th data, right? If you list them up, line them up from data number 1, data number 2, data number 3, data number 4, all the way up to data number 200. Not 2000, say 200. Which one is going to be 70th percentile? If there's a 140th data point, this one behind this is going to be 70%. Above this is going to be 30%. 70th, then this is called 70th percentile. And that's how you find the position of the percentile, right? Okay, So let's go to the PowerPoint again, and that's what they're talking about, computing the index. So if I is not an integer, our example is nice 100 and 200 data points, and it happened to be just nice integer data point. If it's not an integer point, round up to figure out the pth percentile is the value of i's position, right? If the integer pth percentile is average of the value, if I is an integer, then pth percentile is the average of the value in position I and I plus 1, right? So let's go back to the previous example right here. So, you want to figure out the 70th percentile, and the I number happened to be 140. So how do you actually find the pth percentile? Well, you do I being, in our case, I being 140. We also have to do I plus 1, which is 141. So 140th data point, 141st, 141st data point. You add these two data point and then find the average of it, right? That's what this part is saying. This part right here is saying. All right, let's do an actual example. Maybe it'll be easier. Let's say how many data point? We have 70 data point, right? And you want to know the 80th percentile, right? You want to know the 80th percentile. So you put that in the formula right here. See the formula right there? You put 80 there, and then if you find 80, it turns out to be 56, right? 56 is your answer. So if you want to know 80th percentile value, not only you take 56 data point, which is going to be this data point 535, but also you do I plus 1. Remember it says I's position and I plus 1. So not only you take the 56 data, you also take the 57th data, which is right next to this one. So you take these two values, just like you can see in here, you take these two values and take the average of it, which means just add it, divide by 2, and it becomes 542. Now notice that 542 is not in here. It's not in here. But you can also see that this number represents 80th percentile for this data set. So behind this number, there will be 80% of the data. Above this number, there will be 20% of data. That's what this means, 80th percentile, right? So at least 80% of item fall behind this value that we just found, 542, right? 542. At least 20% of the item takes 542 or more, right? So 542 or less, 80%, 542 or more, 20%, right? Box it up like this. Okay. Now, I also recommend you to pause this video every time that you need to pause and think about it and go back to what I just said and take time and try this example on your own. I guess that's one good thing about this video lecture. You can control the speed. I mean, I'm just keep talking and try to explain it, but you can pause this video. You can go back and recheck what I just said and make sure that you understand these examples, right? Now, quartile, basically, you are putting your data into 4 different pieces, right? So you have basically, let me go to the blackboard, show you what I mean. Let's say your data arranged from here to here. You cut it in the middle, and you cut it in the middle of the first half, and you cut it in the middle of the second half. Then that'll, keep this entire data into 4 different pieces. And this is what we call the first quartile, Q1. This is what we call the second quartile. This is what we call the third quartile, right? Q1, Q2, Q3. Now, Q2, being that this is a middle number, and this is also the median value of the entire data set, right? Being that it's a middle number, that's quartile. Basically, that's why they say first quartile, there's 25th percentile. I mean, of course, right? Think about it. Because, Q1 is right here. That means behind this is 25%. Because, as you can see, we cut it into 4 pieces, right? 25%. So these are all 25% each, right? Okay. So when we say Q1 behind this is going to 25%, Q2 behind this is going to 50%, right? Q3 behind this, right? Behind this is going to be what? 75%, right? So that's what they mean by Q1 25% tile. Second quartile is also the median, is a 50th percentile, and third quartile is 75 percentile, right? Okay, so let's say for the apartment rent data, we are looking for that 75th percentile. So as you can see here, put that in the formula, that percentile being 75, right? That's what we're looking for. So put 75 divided by 100 times 70. Why this is 70? Why this is 70? Because we have 70 data point, right? That n being 70. You put it in your calculator, then you get 52.5, which being, you round it up, right? Remember that you round it up, being 53. Remember, let me go back to the previous point. It says right here, if it's not an integer, then it rounded up. First percentile is going to be the ith position, right? So if it's not an integer case, just like this result I is not an integer, so we round it up, and that's going to be the position value. Remember, if it was an integer, if I, the result of this formula become an integer value, then p's percentile is going to be I and I plus 1, get the average, right? We did that in here because result of I was 56. Nice integer number. There's no decimal point. That's what I mean by integer number, right? So if that's the case, we don't just use this number, 56. We use 56 and 57 and get the average, right? That's what we did. So in this example, the apartment rent example, for 75th percentile, the result is not an integer, 52.5. So you round up 53 and that's going to be the third quartile, right? Why is it the third quartile? Because third quartile is what? 75%, right? Third quartile, 75%. Okay, so 53rd data point is right here. If you give them a number, being that this is first 1, 2, 3, 4, 5, 6, if you give all the way, 53rd, right? Each line is 10, right? So this is 50, 51, 52, 53. So this is 53rd data point, and that's being 75th quartile, right? Okay, now we are going to switch gear and we're going to talk about variability, right? Variability, dispersion, or should I say the spreadness of the data set. Now, some data sets are very spread out. Some data sets are highly concentrated, and that's the one that we are going to talk about. Now, some of the variability measure number that represent the spreadness of the data is range or interquartile range or variance, standard deviation, and coefficient of variation. So, we're going to talk about these topics, but just letting you know that these are some of those numbers that we can use to describe what? Describe variability, meaning describe the spreadness of the data set. Right? We're going to try to describe the spreadness of the data set. So, first one is range. Range is simply difference between the largest and the smallest data value. So let me talk a little bit more about this. Let's say you have a data point 1, 5, and 9, and you have another data set. Let's say this is set A, and there's set B, 4, 5, 6. Now, what's the average? What's the mean for this data set? What's the mean? How do you find the mean? You add them up and divide by the total number. So if you add this is like 10 plus 5, 15, divided by 3. The mean is 5. What about here? Well, 4 plus 6 is 10 plus 5, 15, so same. Mean is 5. What about the middle number? Median. Well, median is 5 here too. Median is 5 here too. So if you just compare the mean and the median, they don't really have mode because they don't have any repeating value. If you just compare these two, you know that these two data sets are same in terms of the mean and the median. But you know that this data set is rather spread out. This data set is rather concentrated. But the problem is you can't just say, oh, this is more concentrated, this is more spread out. That's not really mathematical at all. That's not precise at all. So we have to come up with a number. We have to come up with a number that describe whether how spread and how concentrated these data sets are. As they suggest, range is one of those measures. Range is one of those measures. Range is what? Range is difference between the largest and the smallest value. So, if we go back to the blackboard, range for A is biggest value 9 minus 1, which is what? 9 minus 1, which is 8. And let me go push this a little bit up. Range for B is what? 6 minus 4, which is 2. Hey, we just solved that problem, right? We just solved the problem of describing whether these data sets are highly concentrated or highly spread out, just using the range. You know, how simple is that? Largest number minus smallest number. We are done. Well, not quite, because there's possible problem with this range deal. It is simplest measure, as you can see, but it's very sensitive to the smallest and the largest value, right? So let's go back to this blackboard. You know, it kind of works a data point like this, but what if we have a data point, say C, as 1, 9, 9, 9, 9, right? 5 data point. And we have another data point, say D, 4, 5, 5, 4. Well, no, that's not a, let me see. Let me just redo it. 4, say 7, 6, 5, 4. All right. What would be the range for this? Range for this would be 9, the biggest number, minus 1, which is 8. What about range for this set? Biggest number is 7, smallest number is 4. So 7 minus 4, 3. So it looks like this has a larger range and this is smaller range. But if you compare these two data sets, can you really say this is big range spread out data and this is small range compared to this, so concentrated data? Well, not really, because besides this one data point, the rest of data are highly concentrated. This data set, on the other hand, it's kind of spread out, right? So if you just simply use range, it may not capture this type of situation, and saying, oh, because this is a small range, this is more concentrated data, which is not the case, right? So range, as you can see, has its own limit. So, you know, case like this, the apartment rent range would be the biggest value minus the smallest value, 190, right? So there's another measure that we can use, which is called the interquartile range. Interquartile range basically deals with middle 50% of the data. So if you deal with the middle 50% of the data, that means you cut off the smallest 25% and you cut off the largest 25%, and you only deal with the middle 50%. I guess that's also one of the fair attempt. So, you know, data set like this, you cut off the first quartile, and first quartile, you figure out the first quartile, which is this value. You figure out the third quartile, because let's go back to this blackboard that we had. So remember this one? So, you know, you like to work with this middle 50%. Middle 50% being what? Being Q1, between Q1 and Q3. You want to work with this range. So what you do is interquartile range. Sometimes they use IQR as Q3 minus Q1. That's how you find this interquartile range, right? And that's what this PowerPoint is trying to say. Interquartile range is Q3 minus Q1. And you know how to figure out the Q1 and Q3, right? We just studied that. Now, going back to this problem that we just described, using range wouldn't simply describe this difference like that. So we need to have a different measure, a better measure, more sophisticated measure in a way to figure out this range. So one of the attempts to overcome the shortfall of the range is what's called the variance. So variance is a measure of variability that utilize all the data, right? And simply based on difference between each value from the mean, right? I mean, that kind of makes sense. If you say if it's spread out data, spread out from where? What should be the standard? What should be the middle value? If you think about it, when you say spread out, it's spread out from the mean, the average, right? Spread out from the mean. So you, in a way, take that into consideration, the distance from each data point to the mean, and you consider that distance, and you use that to figure out the variance, right? So these are the example of variance. These are the not example, the formula for variance. These are the formula for variance. So let me, you can write down this formula first, right? This is for sample, this is for population. Notice that for sample, we use S square for the symbol for variance. We use this. This is actually called sigma. Sigma lowercase Greek letter. Sigma square, and we use that for the population variance. So I want you to remember S square is for sample, sigma square is for population, right? Sigma square and the population. So let's go to our blackboard. Okay, so let's see. Sample variance. Sample variance, we use S square, and the formula goes x square equal sigma x minus x bar square over n minus 1, right? That's the formula. So what does this, what is this x bar? This is sample mean, right? What about this x? What about this x? This x means each data point, right? This x means each data. You're gonna go one by one. In order to use this, of course, you have to find the sample mean first, and you do each individual data minus sample mean, and you figure out that difference, and then you square it. What's this n? This is sample size, right? This is sample size. So you have the samples. This is the formula, right? Okay. So that's sample variance. Now population variance, however, you use sigma square. That's the symbol. And it's almost the same. sigma x minus mu square over n. Now, this is same thing, each data point. What about this mu? This is population mean, right? This is symbol for population mean. What about this uppercase n? This is population size, right? Population size. I mean, if you compare these two formulas, they are very similar, very similar. One of the difference is that sample case, you divide that by n minus 1. For population, you divide by n. That's one of the major difference. Besides that, these two things are almost the same, right? That's a better writing, I suppose, right? Okay. And what's standard deviation? Standard deviation is basically very, very similar to variance. What you do, you take the positive square root of the variance. So it simply means once you find the variance, take the square root, and that would be the standard deviation value, right? So find the variance first, and take the square root of that variance, and that would be the standard deviation value, right? So how do you find, for sample, you use S, symbol S. For population, you use sigma. And once you find S square, which is a sample variance, you take the square root, right? Just use the square root button in your calculator. And same thing for population, right? Okay. Now, coefficient of variation. You know what? Before we move on, let's do one simple example, right? One simple example. Let me reopen. Okay. So say find the sample variance and standard deviation for the following data. Now, what was the formula? S square was sigma x minus x bar square over n minus 1, right? This was the formula. Let's say our data points are 1, 2, 4, say 4. Oh, actually, no. 4 and 3. Okay, let me see. Let's make this as 5. Let's make this 5. Right, just to make it a little bit simpler. Let's say 1, 2, 5, 4, 4, 5, 3. Okay. So first thing that we should do, we should find the x bar, right? Find x bar first. So let me give you a little bit of time, right? I want you to pause this video and put your calculator out and find this x bar, right? Alright, so how do you do it? Well, you add all the data, 1 plus 2 plus 4 plus 5 plus 3, divide that by number of data point, 5, right? So what would this be? This would be 3, 7, 10, 15, divide by 5, which becomes nice number 3. Well, in real life case, this won't be nice number like 3. It could be all different type of number, but you know, decimal point hanging around, then I want you to keep at least 2 decimal point, right? Okay, so now that we know this is 3, I need to figure out x minus x bar. Let's make a table, column. So, these are our original data. So I need to do 1 minus 3, 2 minus 3, 4 minus 3, and 5 minus 3, and 3 minus 3. Right? These are the original data. These are the x bar that we just found. And then I want to square this. So this being negative 2, square being 4. This being negative 1, square being 1. This being 1, square being 1. This being 2, square being 4. This being 0 is just a 0. Right? Then if you add it up, summation, if you add it up all this, then this becomes 5. Remember, the formula looked like this. So this value is this value, right? So now we need to divide that by n minus 1, right? So we need to do s squared equal 5 divided by, what's n? How many data point? We have 5 with data point minus 1, which is 4, right? Okay, so 5 divided by 4 is what? 1.25. This is going to be our s squared, which is the variance value. Now, once you find the variance, how do you find the square root? Well, the s, which is the standard deviation, is going to be square root of 1.25. If you put it in your calculator, it'll probably give you 1.118. So I'm just going to round it up as 1.12. So this is going to be, our standard deviation value, right? And this is how you calculate the mean and the standard deviation. Okay, I hope that helps. Right? Okay, so we talked about variance and the standard deviation. Now, coefficient of variation is basically these two formula, right? These two formula. So coefficient of variation indicate how large the standard deviation is in relation to the mean. Basically, it's like this. If you're dealing with like huge number, the original data itself is big, each data point is big, then you are expecting relatively large standard deviation value. But if the original data points are relatively small number, you also expect a relatively small data value, right? Small data value. So if that's the case, then you can't just simply compare two different data set with the two different types of number. If one data set describes huge number, if another data set describes a small number, then just because you got bigger standard deviation, that doesn't mean that's more spread out. Or just because you got smaller standard deviation in smaller number set, that doesn't mean that it's more concentrated, right? So you need to see this standard deviation in proportion to what? Proportion to mean. That's what they mean by this, right? In relation to the mean. They want to see the standard deviation in proportion to the mean. Look at this formula, right? This is for sample, this is for population. You know, they use the sample symbol everywhere. This is S being sample standard deviation, X bar being sample mean, and you know, sigma for standard deviation for population, mu for population mean. So you divide standard deviation by sample mean, and then you times it 100 to make it as a percent, right? Just being make it as percent. So that's number. The result of this calculation is called coefficient of variation. Coefficient of variation. So if you do that apartment rent data set, you know, there's a 70 data set and it's relatively big number. I don't think you will do this by hand. You probably use Excel to do this. But you know, if you find the variance, this would be the value. If you find the standard deviation, meaning take the square root, this would be the value. If you want to figure out the coefficient of variation, put this formula, you know the S and the X bar, you know everything. Put it in that, then you have 11.15%. So that 11.15 describe the spreadness of this data set in proportion to its mean. In proportion to its mean, right? The standard deviation is about 11% of the mean, right? That's what this number is telling us. All right. Okay. I hope you can understand this stuff. You can try the homework question that you can see in the lesson, and you know, please contact me, email me if you have any question about homework or this video lecture. Okay. All right.